I'm assuming that you remember what we did yesterday, so I don't have to essentially recap. So what we're going to be looking at today is we're solving a two-dimensional projectile motion problem involving an object starting and ending at the same height. Excuse me. Oh, where that came from. Okay, so what we have there is a long jumper. It's a guy over there, starting over there and jumping in that particular way. This is essentially a projectile. What they're saying there, that's a multi-exposure shot of a long jumper. I'm saying that it's not equivalent to a particle for whatever reason. But when they say the center of mass of the jumper follows a parabola. So nevertheless, what's important is to get the parabolic shape, which I did essentially mention yesterday, and it's the same idea as this, but obviously show it to you now. It's the same as this, but obviously we're starting at this particular point here. So instead of starting at the right here, we're starting at the left. So this is a very important sketch to remember. There's also one like this in your textbook. Like I said, study the sketch, understand what happens here. Okay, so what do we want with this problem? Example 3.3. So what's nice here, they give an angle. So a long jumper leaves the ground at an angle of 20 degrees to the horizontal. So what they mean by that, students, I'm going to get my pen here. Where's my writing pen? This angle over here, the angle is leaving. I should choose a better color. Okay, just give me a second. Let's make it yellow. Yeah, 40. I guess already that's a bit. So it's 20 degrees. Sorry. All right. That's to the horizontal. Hope you get that idea there. Okay. At a speed of 11 meters per second, but they're asking how long does it take for him to reach maximum height? What is the maximum height? How far does he jump? And assume his motion is equivalent to a particle disregarding the motion of his arms and legs. Obviously, I have to make assumptions to make this a bit more easy. Hence, they're talking about the center of mass thing. And then also you use equation 39.c to find the maximum height he reaches. Okay, so first thing what they want here is obviously how long. So maximum height obviously would be the same. So I'll just do it in this shape. The maximum height is obviously here. So this is exactly the same as your one-dimensional motion. They're asking how long does it take, so the time it takes for him to get there. And then at C, they're asking how far does he jump, which is essentially called the range sometimes. You'll hear about these things the more you do it. Okay. Let me just see. We've done already. 1.12. No, I don't think that's correct. But anyway, let's quickly work it out. Thank you for being fast there. I appreciate that. Okay, so the first thing we do, because we're looking for the maximum height, and if you remember our equations, it's Vy equals Voy, Voyx, sorry, Voyt minus, what is our equation, which is a half, we can say half GT, right? It's the same as the other one. Okay, cool. So what we have to know, right? It's exactly the same as the as your one-dimensional motion. What do we know about Vy? What happens at Vy? And also the sketch over here. What happens at the top over here? What's significant of this particular section? What's happening to the velocity? Anyone? Velocity is 0, exactly. So we know that this over here becomes 0. Okay. Right, so we're left with V of y t, just bear with me there, and gt. Not V of y t, sorry man, I was confusing the two over there. Yeah, left with that. But we also know that V of y, if you remember that V of y equals Vy sine theta, right? Remember our V of x also will be equal to, sorry, not V, forgive me, yeah, Vo sine theta, and Vox is Vo cos theta. So you must be, I want you to be very aware of this, the two different, not the two different, the difference between Vy, which is the actual velocity, and then Voy, which is the component part of it. So I want to be very familiar with that. And obviously I explained that. So Voy in this case, so let me first sort this out. So Voy equals GT. Voy in this case is Vo cos theta, right? So, and when they talk about the initial velocity, they mean Vo. It's the actual velocity. I just want to be clear with that. And we can divide that by G. Why am I writing cos, guys? You should tell me better. Sine theta divided by T equals divided by G. My brain's shutting down. So then we have it left with 11 meters per second. Sine angle 20, and we divide that by 9.80. All right, that should give you the time it takes for him to get there. Okay, you guys happy with that? Just get the time for me, the time to reach the maximum height. So what I said is, okay, in this equation, right, the Voy, this is Vo sine theta, right? And Vy is the y, it's the y component's velocity, but this is the component of the initial velocity, which is these two over here. So what I'm saying is I'm taking this Voy, and it's basically that value over here. So obviously I'm rearranging these equations over here to that goes in there, which is essentially on this side over here. Divide that by G, and you're left with T. It's the same as your vertical projectile motion, if you can recall. I don't know if that's clear. 0.38, that's correct. Jizonke, did you get that? That's why it's very important for you to keep up with all the topics as you move along. If you don't know one, you'll be left with one, basically. If you remember if you remember T max in the other thing, it's basically the same thing. Okay, I'm glad you could understand. So 3.8 seconds is fine. Can I get some more decimals there, please, if you don't mind? I'm going to count that leading. It's a 0 here. It's a leading 0. I want some more decimals there. So 3839. I'll just take this one, right? We all get that answer? Perfect. Okay, so I think everyone can do that. And now the next part of the question is, what is the maximum height? So obviously, now that we know the time, we can actually find the maximum height, right? That's kind of straightforward. And again, we're dealing with the y direction here. So delta, not delta y, we can just call it y max in this case, because we know the value. And we know what our formula is equal to, right? So if you recall, it's VOYT minus a half GT squared. Now, obviously, you guys are going to put a plus, but you know, this is the way I always keep it like this. I mean, it's just easy for me to remember. So Y max we're looking for, and Y max is obviously this total distance here. That's exactly the same as the one-dimensional thing. But VOY, we have the value, we know what it is here. It's this 11 sine 20. And now we have the time now. It's 3839 minus half times 9,8 times 0.3839 squared. Okay, so that'll give us that total of how the guys jumped in. Is that clear to everyone? So there's just always be aware of the distinction between VOY and VY and VOX and VO and VX. It's very important to understand the difference between the two. One is a velocity in the x direction, and one is a component of. So can I quickly get that Y max? Akani, non-label.
Sir,
Yes, Sizonke.
is it compulsory for us to use VO for initial velocity? Can we use VI instead?
Yeah, VI is fine. VI is perfectly fine, Sizonke. Yeah, as long as it's initial. Yeah, I'm happy with that.
Thank you.
Thank you. VI is also fine. VI, VF, same story. Melusi, Melusi, what is the answer? Perfect. Right? Should be plug and play here. Am I going too fast, guys? Am I going too fast? You guys following here? Any questions, guys, before I move on? Any questions? Are you guys tired? Miss Musikili, are you winning? Yanda, I didn't see you here yesterday. Any questions, guys? Okay. It's good if there's no questions. So what I'm going to do, I'm going to skip the one. Then I'm going to ask you to basically, they're asking us to use 39.c. So I'm just going to snip that on. Then I'm not, just to give you, that you have it there. So what they want is for you to use this equation. So I'm doing D. So D says use equation 39.c to find the maximum height it reaches. So it's basically the same thing, just an alternative way. So can you guys use this one to find the maximum height? Is that clear, everyone? So we're just going to do D first before I go into C. C, yeah. Just that it talks to the same thing, man. So I want to just show you that. I think I did ask yesterday. There's two ways to do something, and this is typically the other way for especially the height. So clear to everyone. So we can find the maximum height there. Label, Sizonke, Luyanda, there's Musikili, Got it? Bonani? You guys do that? Did you guys get the question? Perfect, Numiso. Precious, did you get it? So now I want to make sure everyone got it. That's the thing. Guys, please ask questions. It's very important. Thank you, Zonke. Okay, right. So I'm gonna talk to the next one, and we can move on. Yeah. So guys, please, when you're done the lecture, always make sure you go over the work, like just 1 hour of going over what you've covered, then another hour doing additional problems. It is very, very important that you do that for extended. Don't be come back failing the subject over here. It's so important. Okay, so C, they're talking about how far does it jump, and they're talking about how far typically. They're typically talking the x, right? So they're talking about this part over here. So we obviously know our new equation over here, and that equation is delta x equals it's v cos theta times time. I hope you remember that. But what's important to note for this time is that we first have to find the time it takes for him to travel all the way from here to there, right? But we only have the time between this particular portion, and that is 0.3839. How long do you think it'll take him to get from here, or from this one to this one? Let's call this A to B. Let's call that C. How far will it take him to go from B to A? How long do you think it'll take him? So that's done. You can do that. And why? So we know maximum height is 0.3839. How long will it take him to get to the to A? I'll wait on you guys. Yes, Akani, I agree, but why? Where do you get that value from and why? Yes, Numiso.
You can hear me, sir? Oh, okay.
Yes.
You've answered already. Oh, I just wanted to say the time it taken to reach the maximum point is the same time taken to reach to the same position, like aligned with the position that it is there. So you must time the time that you've got it to the maximum position by 2.
That is correct, but what is the reason why? There's a reason. I'm looking for a reason why. You got it? Do you have it in Numiso?
Yes,
No.
but just give it the reason.
No, man. I think what I'm looking for is this. I hear what you're saying. Because the shape is parabolic, right? You understand? or it's perfect, and because it's parabolic and it's symmetrical on both sides, that side is equal to that side. Do you understand? Yeah.
Yes, sir.
Because we can't do it for something going like that. That doesn't make sense. You know, like the ones we did before. Just because the shape is perfectly symmetrical, we are able to say it's times 2, which is correct. That's why if something travels like this, you know, for instance, you know, those problems, the one-dimensional, then we can say it takes half and half, you know. But if it just travels like, I'm assuming it's a body that travels like that, we can't really stipulate that. So one must be really cognizant and careful. So definitely the time is 2. So in this case, we know we can find delta x. We know that this was 11. We put in cos 20 here, and it's going to be 2 times 0.3839. And that is definitely correct. I'm very proud of you guys. Okay, so let's quickly get that answer, or the maximum range, or whatever you want to call it. Can we quickly get an answer? Perfect, guys. 100%. 100%. Are you guys happy with this? Okay, fantastic, fantastic, fantastic. Okay, so let us try and see if you guys are brave here, who's able to do this. A nice, not a hard one, but it's an interesting one, right? I'll give you a few minutes, then I can explain the maximum values from a projectile fight from towards. Okay, there's a question, I think. No, it's not. Okay, just give me a second. So I'm gonna post. Obviously, we always do an example, then an exercise, which is next. So I'm gonna see if you guys are fit. Okay. Just give me a second. Pasting here. Yeah. So what you basically have here is a grasshopper, and he jumps 1 meter from rest. Right. So that is 1.00 meters. That's from here to here. And the seal was brave to solve this, and it left at an angle of 45 degrees. All right, so what I want is the initial speed and the maximum height reached. Let's see if we can get that. So it's an interesting one. So they want VO. The one that VO. The one VO. All right, give it a go. The first thing is work with the X and work with the Y, see what you get. The initial speed and then the maximum height reached. Are you guys winning there? Right, are you guys winning over here? You guys need some help? Mr. Mlebo, Dumiso, Colin, you guys winning? I'll give you guys 2 minutes, then I will step into the problem, the exercise. Okay, thank you. I'll just give you, let me give it a quarter past and then I'll come in. Okay, 1 more minute. You guys need more time before I come in? Spierkus, Ndumiso, Leanda, Melusi, can I come in? Mr. Ngobise, Tabo. Bonani. Okay, Tinaye, Tizonke, can I begin? Please do it kind of lost. Good. Yes, okay. No, it's fine. All right. First thing to approach this problem. Someone response, yeah. Is that we're assuming obviously this thing is jumping exactly the same way as a long jumper. You know, it's a grasshopper. I'm sure we've all seen a grasshopper before. And obviously over here we know that Vy is equal to 0. Over here, this is where the maximum height is being reached. And also we know that that has T max occurs here for that. And we also know the x direction, it'll be 2 times T max, right? It's basically what we've just done in the previous example. You know, all the example exercises are always close to each other. The first thing you have to do is set up, two equations. The first one would be x, the one with Vox and times time, right? That's the first equation. You've seen this before. So obviously x is Vo cos theta first times time, right? Okay. So we know that the total distance, right, is going to be 1, right? We don't know the initial velocity. We know that the angle is 45. But what's important to note all the time, remember what we said for parabolic jump or projectile motion, that this will be 2 times time. So we know this is 2 times T max, right? Obviously, it's the same as other problems. So I'm not gonna call it T max. I'll just call it 2 times T, right? It still means the same thing. I hope you guys get that. So that's the first equation, right? The next equation is to do with the y. So maybe I should write it over here. And if you remember the equation, Vy equals Voy, and then minus GT. It's the same as the previous example, which is over here. Exactly the same. It's exactly the same. And we know there on top, Vo is 0. We know that's Voy minus GT. We carry over the GT. We have Voy. We know GT. Okay, let me put it in. So we know what G is 9,8 meters per second. The T is the same, remember, because that's basically half of the other one. That's where we put 2 times there of T max. And we know Voy is equal to Vo sine 45. Remember? Okay. So then we have our second equation. And now we're basically going to be adding 1 into, substituting 1 into the other one. Okay. So then what we do now, we can just say T equals Vo sine 45 divided by 9,8. I hope that's clear to everyone. We do the same over here. We say 1 over Vo cos 45 equals T. I should rather say 2 times Vo cos 45 over T. Does everyone get that? Do you know what I'm doing here? Any questions before I move on? Yes, Tinaye, go for it.
Sir, I used the different equation. I used the range one.
That's fine. Yeah. You mean this one? Delta X
Okay.
isn't the same thing? Yeah. Same thing. Yeah, I'm not writing it full out. Okay. You got the answer then, fantastic. The people, Charlie, Zizonke, Shengu, and Dumiso, are you happy about this? You understand what I did here? Oh, good. Thank you very much. Thank you, guys. I appreciate that. Next step, what we do, obviously, we can, with time is equal, we can make them equal to each other. I'm not going to solve the whole thing. I'm going to just do the rest. So the time is the same. We can make them equal to each other. So we have VO sine 45 divided by 9,8. And we equal that to 1 over 2 times VO cos 45. And obviously we can multiply across. So we have VO squared sine 45 cos 45 times 2, which is that. And that equals 9,81. 9,8, sorry, you know, it's a bad habit. And now we can solve for VO squared. So what is my VO? You guys can do that for me. That's not correct. The answer should be 3,13. Just check that out. Definitely not right. Yeah, it's 3.13. Charlie's got it. Perfect. And also find the maximum height reached. That is your job. Okay. Any questions? Oh, I forgot the 2. Yeah, I see the 2 is very, very important. That's why I mentioned in start already. Very, very important. So you should get 3,13 something. I think it's that. And obviously, all you have to do is take that. Obviously, to get B, you need to find the time, right? And we base up this value back into equation 1 or equation 2. So it's entirely up to you. So you can go 1, you can say 3.132 sine 45 divided by 9,8. Or you can say 1 over 2 times 3,132 cos 45. It's entirely up to you. Yep, is that the correct answer? No, that's not the right answer. And if you do that, I've worked it out just now. You should get a time. Oh, where's the time I worked out now? 3.132 times sine 45. You should get, oh, that's a, oh, no. The time should be 0.2258 seconds. This is T max. Okay, and you take this time and you substitute it into the y max or the y equation, the one here on top. Then you should get your answer. Let's see. It's 0.25, guys. That's the distance. 0.25. You guys are missing something. I think I know what you're missing. So remember, in the y equation, you've got a sine. That's 11. You have to put 3.132 sine of the angle 45 there, or that corresponding time. I'll give you guys some time to do that. Did we all get the answer? 0.25. We all get it? Fantastic. Please practice when you get home. Or when you're at home, but make sure you go over. Okay. Everyone else? Are you good? Charlie, what is the problem? Before we move on. So please check where you missed out on. Yeah. I'll just verify my thing there. 132 times sine 45. Yes, Numiso. Go for the chief.
Oh, I wanted to say something, but I just turned back not to say. Okay, what I wanted to say, because I see that Zeri is not getting it.
Yeah.
I made it for me when I was calculating. I made a mistake because using that equation to find the height, the maximum height. I forgot to divide the locus and the time by 2 in order so that you can substitute it into the formula.
Yeah, you see, there we go. That's one mistake. Because you must remember what time you're working with here. In this case, if you want to find the horizontal time, you're gonna have to time this by 2, the 225. But obviously, this is the time for the height itself. So be aware of that. Yeah, there's 2 different times there. Two different times. Okay, send me a thumbs up if you're good, so we can move on. If there's any questions, you can feel free to ask. Tabo, Okushe, Medisi, Malusi, Luyanda, Bonani. Okay, so seems like we're good. And let's move on. Okay, I told you guys we're going to be moving. So now, what we're just going to quickly do is just develop some new shortcuts for you, right? It's not difficult. I'll just essentially talk to it. And then you can just play around. So I just want to get my snipping tool ready, and then I'll show you. Okay. It's quite easy, but it's just formulas for you to remember. And yeah, okay. So what we're going to do now is just develop 3 equations for the maximum conditions. So, right, this is the next thing in the book. Yeah, and it's quite simple. If you recall, in the previous example, we had T max, right? T max for the height, obviously. And we know that T max was in that equation, at the time to take to reach the maximum height. Okay? But, so we are looking for 3 things. We're looking for the maximum horizontal displacement, which is called the range, right? The maximum horizontal displacement. We're looking for the equation for the maximum vertical displacement, right? The height, and obviously for the time. But so if we want to find the maximum time, if we want to find the maximum horizontal displacement, we are aware that obviously we talk about a projectile being fired, that goes without saying. We are that it's 2 times T max, right? And T max is obviously the one of the height. So we know that for T max, what we found in the other one was VO sine theta, right, over G. Again, this part is coming from this T max over here. That over there. Same thing. Okay? But now we're obviously looking at developing an equation for the horizontal, the max horizontal. So anyway, so we want to find the total time it took, given that we have these variables, we'll know that it's for the total time for the horizontal distance would be 2 VO sine theta over G. Okay, but obviously we want the actual distance. So we know that delta max, right, is equal to VOX times time. And we know that VOX is equal to VO cos of whatever angle. But now we know what time is, right? We added that particular time. So we just substitute the time in there, 2 times VO sine theta divided by G. And we just multiply these things together. And we sit with 2 times VO squared. Or should I, let me rather put it like this, VO squared, 2 times sine theta times cos theta divided by G. Okay, and you guys remember what 2 sine theta cos theta is in metric? You guys remember what that is? Can you guys remember? One of the rules, the double angle rules, Tabo, Colin, do you remember? Yes, it'll give us sine 2 theta. And it'll be VO squared, sorry. And this will be sine 2 theta divided by G. So what you can do is literally plug this in and we can get the maximum thing. So what I want you to do now is use this equation and go test it on the first example we did here. Remember that they wanted the maximum range, this one over here at C. So use this equation and then see if you get that 100 and what's it answer again? 7.94, this one here. So use this equation and check if you get the same answer, just to see if my maths idea is correct. Can we quickly do that? Please, please, whatever I do in class is important, so make sure you go over it. You will be assessed accordingly. Can we just use that formula and check if we get that 7.94? Charlie, Siwapiwe. Perfect, thank you very much. And now, what we're going to do now is do for the Y max, right? So we know delta Y max, I want you guys to actually do it, is equal to VOY T, and remember this T this T is different minus what is it again, half? No, it's G T, right? No, I'm lying to you. This is a half minus a half GT. And remember the time here, in this case, it's not 2 times here. So the time here was given as VO sine, what's it, VO sine theta divided by G. The reason why times 2 there is because we're dealing with the x direction. So over here, I want you to see if we can get this equation over here. One over here. Check if we can get this one here. Delta, yeah. Let's see if we can get it. Let me try as well. Let me see. Okay. You guys got the objective? Do you guys manage to get it? Did you guys get it? Lumiso, Siwapiwe, Tinaye, Precious. Oh. Students, can you guys still hear me? Okay, so it's quite simple. All we have to do is substitute this into this, right? So VOY, we know that is VO sine theta. And we're going to substitute the maximum time over there. And you get VO sine theta divided by G, okay? Minus half G. But what I'm going to do, I'm going to put the G on top, if you don't mind, because it's just G over, G over 1. Then T squared will be VO sine theta divided by G squared. Okay, so obviously this will remain the same. I'll write it again. We're going to have G over 2. This is the same. VO squared sine squared theta divided by G squared, right? And then that's the same. And then sorting this out, dash G and that G will cancel. Not cancel, but we have 1G at the bottom. So we're left with VO squared sine squared divided by 2G. And I can I'll rewrite this again for you. Where's this, my eraser? So you can see it. And if you multiply these guys together, you get VO squared, which is VO times VO squared, sine theta and sine theta, sine squared theta, and we divide that by G, right? You guys agree with that so far? Crazy stuff. Welcome to PCM 150X. Welcome. Are you guys happy with that? Ndumiso, Nonebo, guys are quiet there. And what this essentially is, that's 1 minus half, right? I know you guys can see that. And you're left with VO squared sine squared theta divided by 2G, right? It's 1 minus half, which will obviously give you half, which is that there. So what are you not sure about? Please let me know. What are you not sure about?
It's okay now. I do understand, son. I do understand.
Okay. Thank you, Chief. Siwa Piwe, Ms. Charlie, Ms. Anthony. Tabo, good. Okuche. Once you're done, use this equation for y max. And remember these equations, right? It's going to help you nicely. Smart ways of doing it. Use this equation to verify the answer we found at the first one. Where was it, delta max? See if you can get that 0.72 to 1, this one here. So use that equation that we just developed now to find y max. I hope that's clear to everyone. I hope that's clear. Wendy, are you happy? I'm happy with Ms. Anthony. DC Luyanda. So they use this equation to check if the other one works out. So I'm gonna do it with you before we end our lecture. And where is that again? Okay. Okay. So our VO for the first one was 11 squared sine 20, I believe. And this must also be squared. And then we divide this by 2 times 9,8. Yes. Okay, I thought there's a question. And we should get 0.722. Yeah. Tinaya, can you please check that for me, precious? Wendy, can you check it out for me, please? Lumiso, Tinaya, Precious got it. Fantastic. Fantastic. Mas Mosikili, Okushe. You got it? Yes, Fusi. Go for it, brother. I'm all ears. Numiso, Fusi. Yes, I'm waiting on your thing. Yeah, your hand's raised, so I'm asking. Got the answer? Oh, perfect, perfect. Okay. Perfect. All right. Okay, guys. So we are basically at the end of this lecture. Yep. I'll just depart these words. Guys, please put in the work. Things are going to pick up a bit. By next week, we'll be done with topic 3. And yeah, so I'm not seeing you on a Monday, so I think I'll probably be seeing you Tuesday and Thursday. Because yeah, I don't think you'll have the tutorial session then. I'm realizing that now. I'll probably see you on campus next week. Yeah, so we're losing a bit of time there, but it's fine. But make sure, look on Blackboard, practice what's there in topic 1, practice what's there in topic 2, and practice what's there in topic 3. We've covered quite a bit. We're just shorting to cover relative velocity in topic 3. I will do maybe 1 or 2 more examples with topic 3. Yeah, for this part, and then I'll do relative velocity. And then by the following week, you start topic 4. And I am aware I said we're going to do a class test, but I might postpone that small class test a week after, right? Just so that we cover enough work. It's just a 2% class test, and it's just there for preparation for your main exam on the 30th. So be cognizant, you have 4 weeks left, so please start pushing, right? Engage with the problems on Blackboard. I put up some YouTube channels for extra enrichment you need to go through. And obviously engage with the tutors. You have enough support, and if you really struggle with the problem, engage with the tutor or send me an email and we can maybe do that problem on evening class on Blackboard. So please, guys, try to tackle at least 2 or 3 problems a day. I've given you all the advice. All I have to do is go to the content. You make sure you put in the work. I'm hoping with God's grace we can cover. I'm going to cover all the main topics here, basically in preparation for next year. So next year will be a bit easier for you. We had supposed to be around, let me quickly see, 19 topics to cover. Sorry, 18 I think in total. But obviously, I think it's unreasonable. We might only cover around. It will depend. It might be around 12 or 14. But okay, guys, all the best. Make sure you do the homework as prescribed. I will see you probably next week on campus. But yeah, make sure you cover these problems. Okay, guys, all the best and enjoy the long weekend. Cheers. Well, in advance.